Numbers can mean different things depending upon how they are used. Sometimes we like numbers to be big, like your job salary. And sometimes we like numbers to be small, like being number 1 in your class. And sometimes we like numbers to be within a range, not too high or too low, like your blood sugar. So as statistics students, we need to understand how numbers are used so that we have a way of thinking about their meaning. Let's see how numbers are used to represent amounts, what we call continuous or scale data. With interval data, the scores reflect the relative amount of the variable. They represent an amount on a scale, although the scale itself may not be comparable to other scales. All of the intervals on the scale are the same, however. For instance, a 10-point difference is the same anywhere along the scale. If you are in a 40-degree Fahrenheit room and I raise the temperature to 50 degrees, that is the same number of degree difference as if you were in an 80-degree Fahrenheit room and I raise the temperature to 90. Examples of interval scales would include Fahrenheit or Celsius temperature scale, GRE scores, or intelligence scores. Scores on one interval scale are not comparable to scores on another scale. For instance, is 40 degrees hot or cold? That depends on whether we're talking about Celsius or Fahrenheit. 40 degrees Fahrenheit, 4.5 degrees Celsius, is just above freezing. But 40 degrees Celsius is 104 degrees Fahrenheit, uncomfortably hot. Even on the same scale, the numbers are not comparable. 40 degrees Fahrenheit is not half as hot as 80 degrees, or twice as hot as 20 degrees. Nor do the numbers represent an absolute amount in which more is better. More room temperature does not equal more comfort. Being in a room 35 degrees Fahrenheit is uncomfortably cold. A room 70 degrees Fahrenheit is comfortable, but a room 105 degrees Fahrenheit is uncomfortably warm. You can have a 0 point on an interval scale, so the interval scales can have negative numbers. But the 0 point on an interval scale is arbitrary. It does not necessarily mean anything. For instance, on the Celsius scale, 0 degrees Celsius is the freezing point of water. But in the Fahrenheit scale, 0 degrees Fahrenheit is just another number on the scale. There is, however, a temperature scale in which absolute 0 means something. We'll talk about that in a moment. Interval data are quantitative in nature and are continuous data. Ratio data occur when the scores reflect the true amount of the variable that is present. Scores are said to be ratio if they are measuring an amount. The intervals in the ratio data are consistent. 100 is twice as much as 50. Examples of ratio data would include ruler measurements, weight in pounds or kilograms, amounts of money, or the Kelvin scale of temperature. Because the scale is measuring amount, numbers are comparable between scales. Having $0 is the same as having 0 yen or 0 euros or 0 Deutschmarks. You could create a conversion scale between any two denominations. The scale has a base starting point of an absolute, non-arbitrary, true 0 value. 0 indicates a lack or absence, so the scale cannot have negative numbers. You cannot have less than 0. 0 degrees Kelvin is absolute 0. It means cessation of molecular motion. There is nothing colder than absolute 0. In the same way, you can't have $0. Well, you might look at your checking account and see that you're overdrawn, but that does not mean that you literally have negative $100 in your account. It means that you owe the bank $100 and they want 100 real dollars. There's no such thing as negative $100. That's just an accounting trick to use to keep track of who owes what. In terms of real money, you can have $0. You can owe people more money than you have, but you cannot have literal negative dollars. Ratio data are quantitative in nature and are continuous data. Let's review the qualities for these measurement scales. SPSS calls nominal and ordinal data nominal and ordinal in a column labeled measure. SPSS calls both interval and ratio data scale data. This means you will not need to distinguish between interval and ratio, only that you have interval or ratio as opposed to nominal or ordinal. Both nominal and ordinal scales are categorical data. Interval and ratio data are continuous. Nominal and ordinal data are always discrete data. That means that you can only have whole numbers. Interval and ratio data are typically continuous data and allowed to have decimals or fractions, although they could, in some rare circumstances, be discrete. For instance, IQ tests give only whole number values, even though theoretically it is a continuous scale. If I ask you how many songs you have in your iTunes collection, it could only be whole numbers, even though you may have thousands of songs. What about the role of 0? In the nominal scale, 0 is only a name. It does not have a true meaning. You cannot have a 0 in the ordinal scale. There is no 0 place. Interval scales may have a 0, but it's arbitrary and does not have a specific meaning typically. Only in the ratio scale do you have a true 0 in which 0 means absence of any quantity. It is also only in the ratio scale that you can have a true 0. In nominal and ordinal scales, the measurement units are not equal. The difference between first place and second place is not the same as the difference between fourth place and fifth place. On the other hand, interval and ratio measurement units are equal because they have a consistent underlying interval. The difference between $1 and $2 is the same as the difference between $4 and $5. Can the scale have negative values? I've never seen negative numbers used on a nominal scale, although theoretically it would be possible. Ask your football coach if you can be -23. Ordinal scales cannot have negative values because they cannot have the 0 place. Interval scales can have negative values, such as 25 degrees below 0, but it's not common. Ratio data has an absolute 0, so it cannot have negative numbers.